السلام عليكم ورحمة الله وبركاته. ننتقل دلوقتي يا شباب إلى بيج نمبر 6. زي ما أنت شايف كده عنوانها Indeterminate Quantities أو الكميات غير المعينة. إيه المقصود بيها؟ إحنا كنا ناقشنا قبل كده في محاضراتنا السابقة هذا الموضوع. لو تتذكر قلت لك إنك أنت في بعض الأحيان بيقابلك واحد من 7 كميات ما نقدرش بصورة مباشرة نقول لك قيمتها كام. ال7 كميات دول لو تتذكر معايا قسمناهم في حالة 3 عائلات هما كالآتي. العائلة الأولى لو تتذكر كانت عبارة عن 0 على 0. العائلة العضو الثاني في العائلة الأولى انفينيتي على انفينيتي. العائلة الثانية كانت عبارة عن 0 تايمز انفينيتي، والممبر الثاني اللي فيها انفينيتي ماينس انفينيتي. والعائلة الثالثة عائلة الباورز اللي هي 0 to the power 0 و infinity to the power 0 و 1 to the power infinity. ما تنخدعش بالشكل الموجود فيه، يعني ربما بعضكم يظن ان دي equals 1، لكن طبعا ده مش بالضروره يكون فعلا حقيقي. البعض ممكن يظن ان دي القيم اللي هنا بصفر، او واحد يرد عليه يقول كل ما يكونش بلا نهايه. على سبيل المثال انت قلت ان الصفر في معنى غير الصفر غالبا في معنى نهائي، الواحد يقول لا من المعنى اللي تقدر الصفر، فانت ما تقدرش تتوقع القيمه كام. يقول لك الله ما في معنى نهائي ما بصفر، برضه اقول لك اثبت لك حاجه ما تقدرش تقول الكلام ده بصوره مباشره. 0 to the power 0 equals 1، لا هنفحصها وهنوريها لك. قد تكون 1، قد تكون هاف، قد تكون ماينس 3، ما تقدرش تتوقع قيمتها كام بمجرد النظر، لابد من معالجتها بصوره رياضيه بصوره سليمه. فتعال نبدا على سبيل المثال بالعائله الاولى نفحصها كويس ونقتنع ان ما نقدرش من اول وهله نقول عليها انها بتساوي 1. فانت عارف على سبيل المثال لما اضرب صفر في 3 تطلع صفر. طب لما اجي اقول لك صفر على 3 برضه بصفر، بالله عليك هل الصفر اللي موجود في الطرف الشمال ده ذا سيم لايك زيرو اللي جاي من هنا؟ لو انا هفترض ان الصفر ده هو الصفر ده، هل هنا نفس القيمه مره ضرب في 3 ومره تقسم على 3؟ بالله عليك هل اليمين هو قيمه الشمال؟ طبعا لا. وبالتالي لما اقسم صفر على صفر انا مش عارف اجيب منين الصفر اللي فوق، مش عارف اجيب الصفر اللي تحت منين. لو انا متاكد I am sure that the source of the zero numerator is the same source of the zero denominator، لا جدال ولا شك في الحاله دي ان الصفر الكلي اللي فوق زي الصفر الكلي اللي تحت، خلاص لا جدال ان الصفر ده على الصفر ده هيؤدي الى 1. لكن هذا ليس بالضروره يكون ده صح. خد مثال بسيط جبري بسيط قوي. انا مثلا اقول لك على سبيل المثال x سكويرد ماينس 4 divided by x minus او x plus 2 as x equals minus 2. هتيجي تعوض هنا تجد ان اللي فوق بكام؟ بيساوي 0. طب واللي تحت الدينومينيتور بكام؟ بزيرو. Can we decide it is 1؟ لا. طب ليه؟ طب تعالى نشوف. أو كان فاكتورايز النوميريتور إلى x minus 2 times x plus 2 divided by x plus 2 as x equals minus 2. دلوقتي زي ما انت شايف كده بمنتهى البساطة cancels x plus 2 with x plus 2. This bracket, this quantity, this sub-expression gives 0 and this gives 0. As you see, they are the same quantity, so the same 0 for this and this. We can directly cancel this with this, and it remains with x minus 2 as x equals minus 2, which is minus 4. What? 0 divided 0 is minus 4? Yes, it is minus 4, not 1. If it was x squared minus 4 divided by x minus 2 as x equals 2, it will result in 4, not minus 4. This is still directly 0 divided by 0, like this, 0 divided by 0. But the first one is minus 4, the second one is 4. So we can never decide from the first glance is it 0 divided by 0 is a 1. We have to investigate it and look for what we call the zero factor in both numerator and denominator, and they cancel the same zero factor in both numerator and denominator. Okay? Let us go to page number 7. He concentrates on some examples that gives you the 3 families. As you see, first family may originate from sine x divided by x as x equals 0. Both are zeros. Or x cubed minus 1 as divided by x minus 1 as x equals 1. Is still 0 over 0. Also, when 3x squared minus x plus 1, 2x cubed minus 4 directly gives you infinity minus infinity divided by infinity. We can decide. We'll study this inshallah and we'll prove it is 0. Not 1 or another value. It is exactly 0. We'll see it after a few lectures inshallah. We'll prove it is 0. Also, for the second family, we have x times cotan x as x approaches 0. As you know, cotan 0 is 1 over tan 0. Tan 0 is 0. 1 over 0 is infinity. So this will directly results in 0 times infinity. Also, 1 over x minus 1 minus 1 x over x squared minus 1. When you substitute directly x equals 1, you will have the infinity minus infinity. Also, for the third family, you can see sine x to the power x as x equals 0 will result in 0 to the power 0. Ln x minus 1, as we studied before. If you remember, I told you 3 important values. Ln 0 equals minus infinity, ln 1 equals 0, ln infinity equals infinity. Here, as x equals 1, you will have ln 0 to the power 0. Ln 0 is minus infinity, so we have minus infinity to the power 0. Okay? Let us have an algebraic example. As you see, in page 8, he asks us to estimate the value of limit x over root 1 plus 3x minus 1 as x approaches 0. By direct substitution, you have 0 divided by 0. As we said, we can't decide from the first glance it is 1. No. He asks you to find or estimate its value by tabling values for x and obtaining the value of this quantity, and by graph. Let us use the first tabling values. As you see in the given table, we have the table is divided to 2 parts, one to the left and one to the right. One just before 0, it is 0 minus, and one after 0, just after 0, 0 plus. As you see from the given values, you tend the value of the limit tends to approach 0.6666, which is 2/30. Just after 0, the calculated values as you see makes the limit tends to be 0.6666, which again 2/3. So we can estimate the value of this limit to be 2/3. This is by tabling the values of the given function under the limit. Now he uses a graphical approach. First, he draw y equals 3x plus 1, as you see, by a line like this. Then he took the root of this function. This is a straight line, as you see, first degree, y and x, so it is a line. Then he took the root of this function, 3x plus 1, which has a curve, as you see in the graph, like this. Okay? Then he made an operation for this function. He subtracted 1. If you remember, this is called shift downward. Shift downward. Okay? So the new graph will be like this. If you remember, we said downward shift is the same if you make upward shift for the x-axis. If you were with us in this that lecture, you remember what we have already did. Okay? Then, or finally, he drew the line y equals x, the 45, if you remember, y equals x. Okay, this is y equals 3x plus 1, all minus 1. Okay, then we divided this function y equals x by the function y equals root 3x plus 1 minus 1. Then you have that curve drawn in green, as you see in your lecture, and at 0 the curve intersects the y-axis at the point 0 and 2/3. 0 for x, 2/3 for y. So actually the limit is 2/3. Besides, we can prove that the limit is 2/3 by a third approach. How? By algebraic analysis. Is how you see limit x divided by 1 plus 3x minus 1. We can multiply what we said, we studied before, the conjugate of the denominator. مرافق المقام 1 plus 3x minus 1 divided by 1 plus 3x minus 1 plus 1 plus 1 plus 1. Okay? This is called, these quantities in red are called conjugate of the numerator. The same in numerator, same in denominator, so the value of the limit is still the same. When you simplify the denominator, we obtain 1 plus 3x minus 1. And in numerator, we have 1 plus 3x plus 1. This will result in 3x. 3x with x, we will have downward 3. So we have finally 0, 1 plus 0 is 1, 1 plus 1 is 2, and 3 is the denominator, so it is 2/3 as we said before. إن شاء الله المحاضرة الجاية نكمل الموضوع.